and center in the scientific world. No longer just science fiction. I want to understand how it works in string theory, in fundamental physics, and then potentially in cosmology in large extra dimensions. How significant is this in our understanding?
Let me tell you a story. When I was a child growing up in San Francisco area, I used to visit the Japanese tea garden and to visit the carp swimming just beneath the lily pads in a two-dimensional pond. I used to spend hours looking at them. They would swim forward, backward, left and right. Their eyes were to the side, and they couldn't see me. I was in the third dimension. I was in hyperspace. They were totally unaware that there was a universe beyond their pond. And then I thought, well, what happens if I reach down and grab one of the fish, lift the fish up? Maybe that fish was a scientist, and the scientist would say, bah, humbug, science fiction. There's no world of up. Up does not exist. Well, I would grab this scientist, lift them up in the world of up, hyperspace, the third dimension. What would he see? He would see beings breathing without water, a new law of biology. Beings moving without fins, a new law of physics. And then I would put the fish back into the pond. What kind of stories would he tell? Well, today, we physicists believe, we cannot prove it yet, but we are the fish. We spend all our life in three dimensions. We go forward, backward, left, right, up, down, thinking that anything beyond our pond, anything beyond our little puny universe is science fiction. We say, bah, humbug. We can't say that anymore because the concept of higher dimensions now is the biggest game in town. You see, in three dimensions, there's not enough room to put all the laws of physics. But when you go to this larger pond, this pond of hyperspace, then all the laws of physics just fit together like a jigsaw puzzle.
In our three dimension, the laws of physics are there. We can explain things. But there are lots of pieces that seem to be random, that you have to enter constants by hand, and so you might have 30 or so constants of physics and more in cosmology, and they look like they all have nothing to do with one another.
That's right. I like to think of a crystal. Let's say a crystal, a beautiful crystal, shatters and lands on a tabletop. And they're little insect-like flatlanders living on this tabletop. And they say, let us reassemble the crystal. Well, they bring it together, and then they have one crystal. It's called the quantum theory. They assemble other pieces of the crystal. It's called relativity, theory of space-time. But then they try to bring these two chunks together, and they cannot. No matter how they bring these chunks together, they cannot. And then one day, someone says, let us go to the world of up. Let us move one crystal up and then fit it into the third dimension, and it will create a beautiful unified crystal. That's where we are today, we think. We live in a three-dimensional world. We see pieces. We see the electromagnetic force. We see gravity. We see nuclear force, little pieces of this unified field theory. We bring them together. Now we have the theory of the quantum theory, the theory of the small, the theory of atoms. We have the theory of Einstein, the theory of space, time, relativity, but they don't fit together until you go into hyperspace, and then they fit together beautifully. So in this crystal, the crystal exists in a higher dimension, but it eventually cracked apart for reasons that we are still trying to understand. And the three-dimensional world we see today is quite broken. Now, where are these higher dimensions? Look at smoke. Smoke permeates throughout a room. Smoke permeates in all three dimensions, but smoke never disappears. Smoke never floats into the fourth dimension. Therefore, a fourth, fifth, sixth dimension has to be smaller than smoke. But atoms also don't suddenly drift away into hyperspace. Therefore, these higher dimensions have to be smaller than an atom, or else our universe would float away. Okay? So we think that at the beginning of time, there was this perfection of 10 or 11 dimensional hyperspace, but these other dimensions curled up, so small that atoms cannot leak into these higher dimensions.
So these are the kinds of that look from a distance as if they're one-dimensional, but when you get very, very, very small on scales that are much, much smaller than an atom, they actually would curl around each other and be like a straw.
That's right. So that the universe we see around us really is hyperdimensional, but we can't see it because these other dimensions have curled up. They're too small to be observed.
Compactification is the word that I think string theorists use. That
That's right. If I have a tabletop exists in 2 dimensions, but I can roll it up like in a cigarette, roll it up, and then I see this 1-dimensional thing, which is actually 2-dimensional if I get very close with a microscope. So we think that these higher dimensions are all around you, in your body, in your living room. The pond touches the 3rd dimension at every point. So if I have a pond and we are the fish swimming in the pond, and you ask the fish, where is the 3rd dimension? The answer is everywhere.